image processing techniques in order to Welcome back, everyone. In this lecture, we're going to focus on actually providing our own custom seeds or markers with the Watershed algorithm. Previously, we used a bunch of image processing techniques in order to automatically grab foreground markers. That was the 6 markers for those pennies. And then we had the Watershed algorithm then decide, based off those markers, where the actual segments should go. However, a lot of times with the Watershed algorithm, it's easier if you can just click on the image yourself and have that set as the seed for the marker, and then the Watershed algorithm will automatically update its segmentation based off the seeds you provide. Let's go ahead and see an example of this. All right, the program we're actually building will look something like this. We're going to be able to open up an image. Here I have an image of a road with some sky. It's a sunset. Notice there's an ocean here. There's some mountains, and then there's a bridge. I'm going to be able to selectively click on different segments of this image. So right now I'm clicking and a color circle is popping up on the sky. And then I can change color and choose another segment of this image, such as these mountains over here. And notice what's happening on the right. This is the Watershed algorithm automatically updating its segments. Then I can choose a different color on my keyboard and maybe also segment out this ocean. So then I'll use that as well. And maybe I want one last segment for the bridge. So I'll choose another color here and then segment out the bridge. Okay, and you can begin to see, however, the custom seeds are able to automatically segment just based off a few points that you provide that share the same color. And if you want to get more complicated, then you can start looking at minor adjustments here, or then adding more color that here on the green, etc. So it's up to you how far you want to take this project, but hopefully you understand the idea is that we're setting seeds and then we're going to automatically segment them. So let's get started by checking out the code. Okay, so I already have our basic imports here of CV2, NumPy, and Matplotlib. The next thing we need to do is actually read in the image and then make a copy of it. So I will call the image road and say CV2 image read, and then say data / road image.jpg. Keep in mind, you should be able to extend this idea to any of the image in our data folder or any image you prefer. And then what we're going to do is also make a copy of the image that we can play around with. We'll just say np copy of the road. You could also say road.copy, open and close parentheses. Let me quickly show you what this looks like, even though we've already seen it. It's essentially this image. Notice I won't be doing color correction in this case because we're going to be using OpenCV to view the image, not Matplotlib. So I will comment this out and continue. Next, I want to create an empty space for the results to be drawn onto. And I'm going to base this off the shape of the road. So I have road shape here. It's 600 by 800 by 3. Remember, if I just add an indexing call, :2, it'll give me back the first two, 600 and 800. That's what I'm going to use here. We'll say marker image is equal to, and I'm going to set up an image of zeros of the same shape. We'll say road shape, and this will actually just take in the X and Y, and this will be data type. We'll go ahead and have this be 30-bit integers or 32-bit integers. And I'm going to create one more for the segments that we'll also be drawing on. We'll say np zeros, and then say road.shape, and then say dtype is equal to np uint8. All right, so now I have markers and segments. The main thing to notice here is that the marker image itself, its shape is just 600 by 800. The segments image, its shape is 600, 800 by 3, even though they're all just zeros, they're all black. Next, we need to decide on how to actually create the colors for the markers. For this, we're just going to use the Matplotlib color mapping. If you check out the link in the documentation, that is the link that's in the notebook that leads to the documentation, it'll take you to this color maps reference. We've already seen this page a little bit when talking about viridis versus gray color mapping. If you scroll down, you'll notice we have qualitative color maps, and these qualitative color maps are going to be indexable. That way we can actually just grab colors off of these mappings. So it's up to you which actual color mapping you want to choose. We'll go ahead and just use tab 10 since it has really distinct colors. In order to use this, all you need to say is from matplotlib import cm. Then you say cm. If you hit tab, you'll notice a list of all the color mappings. We're just looking for tab 10. And then if you pass in a single digit, it returns back red, green, blue, and then alpha parameter. Notice they're all scaled between 0 and 1. We're also going to need to change that so that they're scaled between 0 and 255. So the first thing we're going to do is actually just index off just the red, green, and blue value. So we'll say CM tab 10, and we're just going to show the examples for the first one. So if we index :3, that gives us the red, green, blue, and then what we want to do is multiply this by 255. So we'll cast this as a NumPy array, and then we can multiply it by 255, and then we get back this array. And the way our function is going to work later on, we actually want this to be a tuple. So we're going to want something that at the end of the day looks something like this: a tuple of red, green, and blue values. Keep in mind, technically, since we're using OpenCV, we should be switching this red and blue channel, but all we really care about is that we have distinct, unique colors, and this should be good enough for our use case. I would encourage you to explore the color mappings and see how the rest work out, but this is enough for our case. So I'm going to functionalize the operation we did here. So I will say def create RGB I, and then we're going to return this, except instead of 0, we're going to say I. And now what I can do is I can say for I in range 10, I take a list of colors. So let's make a empty colors list, and then say colors append, and then say create RGB of I. If you run that and now check out what colors looks like, it's exactly what we need. A list of tuples here where each tuple is some sort of unique red, green, and blue color mapping that is related to this color map. Again, the channels of red and blue are switched, but that's not a big deal for us. Okay, so now that we have that ready to go, it's time to set up our callback function. So we're going to come back down here, and now it's time to set up the process that you're probably already familiar with. Remember, there's essentially 3 major components. There's the global variables that we'll be defining. There's the callback function, and then there's the while true loop that actually does things. While true. Okay, so we're going to separate these into their separate cells so we can work on them one at a time. The global variables one, that one's actually pretty straightforward. We're just going to have a variable to start off with as the current marker. The current marker, this is essentially what was the color choice. So this is the index position for this list of colors. We'll start that off at 1, and then we'll say marks updated is equal to false. This checks if the markers have actually been updated by the Watershed algorithm. Okay, so 2 global variables, not a whole lot to work with. Just check if the current marker, what it is. This will be adjusted depending on the user providing a number input, and then check if the markers have been updated. Next, it's time for our callback function. We're going to keep this simple. We'll just call it mouse callback, and then we'll pass in the events, the x, the y, the flags, and then the parameter call. And the global variable we're going to take in is just marks updated. This current marker will actually pass that back using the while true loop. So we're going to check, have the marks been updated? And let's make sure that's a D there. So have the marks been updated? That's what we're passing in globally. And we'll say if the event that's passed back is equal to CV2 event, if the left button is pressed down, then the person is clicked and it's time to draw the circle. So how do we actually draw the circle? Well, we need to draw essentially 2 circles. One for tracking the markers that we send back to the Watershed algorithm, and the other for actually displaying on the user image that the user is going to see. So we will say CV2 circle, and we have the marker image. The circle is going to go at positions X and Y where the mouse was currently located. We'll give it a radius of 10. You can always play around with that. And then we'll pass in the current marker. So remember current marker there. And then we'll say -1. So this guy, this circle, this is for the markers passed to the Watershed call later on. So that's why this actually isn't really a color. Okay. Next is what the user sees on the road image. So in this case, we'll say CV2 circle. And on the copy of the road image, so on road copy, we'll put a circle on X and Y. It have a radius of 10. And then we'll index off that list of colors the current marker. And this one also be solid, so we'll say -1. And then we'll just say that the marks have been updated. So we'll say marks updated is equal to true. So run that. All it's doing is checking, did someone click on the left mouse button down on that road image? If so, take a note of where the marker is, and then also put a circle where the user currently clicked. And now it's time for our while true loop. But before that, we want to connect the callback to a named window. So we'll say named window. We will call this road image, and then say CV2. And let's set that mouse callback to the road image window, and then we'll provide mouse callback. Then we will say while true. Let me create a little more space here. We will say while true, go ahead and show the image show, and we're actually showing two windows. One is the results of the Watershed segments, and that's that window that starts off black. So that's why we have segments. Remember segments, if we come all the way back up here, that was NP zeros with the exact shape of 600, 800, and the color channels. So we have segments there ready to go for us. And then we'll also be showing the road image. So we'll say CV2 imshow road image, and we'll be showing the road copy there as it gets updated. Next, we have three main things we need to do. We want to be able to close all windows. We want to be able to update the color choice. And then we want to actually be able to update the markings. So first one that's easiest is just closing all the windows. I will say k is equal to CV2 wait key, wait for a millisecond, and then I'll say if k is equal to 27, that stands for the escape key, go ahead and break. So if you hit the escape key, it'll break out of this while true loop. And so at the bottom, outside of this while true loop, I will say CV2 destroy all windows. Notice again, this is outside of this while loop, just as we've done in the past. Next, we need to figure out how to actually update the color choice. So before we do that, there's actually going to be kind of a part A to that one, and it's clearing all the colors. So instead of having to restart this program over and over again in case you want to play around with it, we should be able to clear all the colors. And we're going to do that when the user presses the C key. So clear all the colors upon pressing the C key. We'll say LFK is equal to ordinal of lowercase c. So that means that the C key was pressed. We're going to essentially reset all the copies of all the images. We'll say road copy is equal to a copy of road. You can also use np.copy there. We will say marker image is equal to np zeros, road shape, :2, and we'll set the data types equal to their integers. That way they don't get messed up when they're being drawn on. And we'll also say segments is np zeros, road.shape, d type is equal to np uint 8. Okay, so this essentially just resets these two images to what we initially had them as up here in these two lines. So it just resets them to black or to empty. So we have our marker image that's holding all the markers for the Watershed algorithm, and then we have the actual segments displaying the segments. And those will all be cleared if the user presses the C key, and we'll also make a fresh copy of the road. Next, we want to update the color choice. So we'll say if the key being entered is greater than 0, and if the characterized version of the key being entered, that's the actual number, if it is a digit, then what we're going to do is set the current marker equal to the integer form of the character of k. So this k, when you actually click on your keyboard, it sends a specialized number code, and often that will have nothing to do with the actual number being pressed. So I think if you press 2 on your keyboard, it sends back the number 51. So what we want to do is transform that to its corresponding character, which is what the CHR does. So it turns that key press from 52 to the actual number pressed 2, and then that's still a string, so then we transform that string into an integer, which we can then set as our current marker so that we can do an indexing call up here. Okay, so all this is doing is just basically reading in what did you press on the keyboard as far as the numbers 1 through 9 are concerned. Okay, so we check the current marker and reset our updated color choice. Then, if the marks have been updated, remember the marks are updated if someone ever clicks down on the left button. So we want to update both images. So if the marks have been updated, then we'll say marker image copy is equal to a copy of the marker image. And then we'll say CV2 will call Watershed on the road image with the marker image copy. And the reason we do a copy here is because this marker image is still being manipulated in the window. So we want to make a copy of it so we can pass in the copy to the Watershed algorithm. Then once we've done that, we can say that the segments are equal to np0s road.shape, where the data type is equal to np 8-bit integer. And we'll say for color index in range, and we need to decide the range here. So this is the number of markers provided. So one of the other variables we can have up here in the global variable or defined earlier is just the number of markers we actually intend to use. So let's just say there's markers 10. That would be the numbers 0 through 9. So we'll say comments here 0 through 9. Go ahead and run that and save it. So we have number of markers. Again, if this colors list is bigger, you can maybe have more than that, but it'll get a little tricky trying to record a number 15 instead of just the numbers 0 through 9. So we'll say in range and markers. Then the segments of marker image copy equal to the color index. We'll then set that equal to the colors at that particular color index. So this is pretty much what is coloring the segments. And it's doing it essentially through a NumPy call. Okay, so what we're going to do here is run this and make sure everything works. Let's go ahead and do Shift-Enter here. So here are our images. Let me go ahead and hit C to clear. So anywhere you click, you should eventually see a dot. And if you're using tab 10, the first dot is probably going to be blue because that's the 1, unless you happen to switch out the blue and red channels. Go ahead and on your keyboard, hit C, and then that should immediately clear it again. Next, what we're going to do is choose a different color. So go ahead and click a number on your keyboard, and then click on the sky. So this is number 2 for me. Click number 3 on your keyboard, and then hit maybe the ocean over here. Then hit number 4 on your keyboard, and select these little groups of mountains. Do a couple clicks here, and then maybe select 5, and go ahead and select the road. And you should eventually see the image segmentation happening over here on the right. Remember, you can always hit C to clear out the image again. So let's try this again. Maybe try with the road first. So we'll go ahead and do a couple of lines there for the road, then choose the color 2, do a little bit for the mountains here, then 3 for the sea, and then 4 for the sky. And there you can see the image is being segmented based off the marker seeds that you provided. And really, in fact, you don't need this many seeds, but it is good practice just in case, the image is quite noisy or something. All right, so that's it for this project. You now understand how to set up your seeds manually based off an image, and you can click on it, do the callback, and then call Watershed to automatically segment the image for you. Thanks, and we'll see you at the next lecture.